Okay, so what we're doing now is we're graphing two different things on the same graph. But they also have different domains. So let me show you how we're going to go about doing this. Let me insert a graph. Okay, so the first thing we're going to graph is f of x is equal to 3 if x is less than or equal to 0. Well, do we agree this is f of x is interchangeable with y? So this is the same as saying y equals 3. What kind of graph is y equals 3? A straight line. What kind of line? It is a horizontal line. It is a horizontal line. Remember, if y just equals a number, that's a horizontal line. You turn that y upside down, it looks like an H for horizontal. So when y just equals a number, it's just a horizontal line. So forget about our domain restriction because it's saying if x is less than 0. Let's just see what this line would look like. We'd go to y equals 3, 1, 2, 3, and we would draw a line through y equals 3. Do we all agree that's what y equals 3 looks like? Okay, but that's not what we want because I gave a domain restriction. What was my domain restriction? If x is less than or equal to 0. So where is x less than or equal to 0? This part of the line going where? Left or right? Left. So this pink is the only part of my graph because of my restricted domain. You don't write things down, Dravid?
I did.
You didn't graph it.
Was it stated? Because a graph is graph.
Okay. So the next part. Is saying, well, now we're going to have f of x is equal to negative 3 if x is greater than or equal to 0. Well, remember, f of x is interchangeable with y. So y equals negative 3 if x is greater than or equal to 0. Once again, y equals a number. What kind of graph is that? That is a horizontal line at y equals negative 3. 1, 2, 3. So it would pretty much look like this green line. But I've restricted the domain. What is my restricted domain? It's only in the scenario that x is greater than or equal to 0. So where is x greater than or equal to 0? Here, going to the right. So what should I do with the left part of that line? Erase it. And that's our split graph. That's it. All right. You all try this one. So I threw a little curveball in here, just trying to see how you go through it.
Is it always going to be like 0? Like x is greater than 0? Or could it be another number?
No, it could be another number. I'm going to do all different scenarios.
For the thing the problem we did before this, is it not a function because there's like two y values for one x?
Well, yeah, like each individual thing is a function, but this isn't considered like function or non-function since we have two different things. But yeah, if we were doing like the vertical line test, it would fail because they both cross at 0. Great, we ready? So it says f of x equals 1 if x is greater than 0. Well, y equals 1 looks like this. Do we agree? Right, but now it's saying if x is greater than 0. So I'm erasing the left part of my line. Is y equal to 0? No, so what do I have to do? I have to put an open circle and then go to the right. Then we have f of x equals 0 if x equals 0. What is that saying? Y equals 0 is basically the x-axis, right? But then it's saying it's only when x equals 0. Aditya?
That just makes it a point at 0, 0.
You got it. This just makes it one single point at 0, 0. Because that's the only spot where x equals 0. Then we're going to have y equals -4 if x is less than 0. So 1, 2, 3, 4, open circle, but now we want x is less than 0, which goes this way. How many people got it completely correct? Good. Let's step it up a bit.
Oh, yeah.
What have I put in here now? Absolute value. What's absolute value look like? A V. Absolute value looks like a V. Okay, so the first one is saying y equals -1 if x is less than -1. So I'm going to go to y equals -1, but now it's saying x is less than -1. So I'm going to put an open circle on -1, and then where's my arrow going? To the left. Good. I'm going to skip the middle one and go to the other one. Y equals -1 if x is greater than 1. All right, so now again, I'm going to y equals -1, but now x is going to be greater when x is greater than 1. So again, open circle, and then where am I going? To the right. Is everybody okay with those two so far? All right, now we have our middle one. Y equals the negation of the absolute value of x if -1 is less than or equal to x, which is less than or equal to 1. Well, generally the absolute value is centered at 0, 0 and opens up, right? Or vertex 0, 0 opens up. What does the negation do? it makes it frown, it makes it open down. So what I need to do is they're giving us a restriction on our domain. They're saying we're just between -1 to +1. So what I need to do is I need to see, since that's where my domain starts at -1 and it ends at +1, I need to see my endpoints of this absolute value graph. So how am I going to do this? I'm going to plug into the chart. I have my x value. I have y equals the negation of the absolute value of x, and then I will have my xy coordinate. So I want to know what happens when x is -1. Well, when x is -1, y will equal the negation of the absolute value of -1. What's the absolute value of -1? 1. The negation of -1 is -1. So the coordinate here is -1, -1. Do we agree? Okay. Then let's see what happens when x is 1. So we're going to have y equals the negation of the absolute value of x. So y equals the negation of the absolute value of 1. What's the absolute value of 1? 1. The negation of 1 is -1. So now the point is 1, -1. Do we agree the vertex is still 0, 0 since we didn't shift left or right at all? All right, so what do we know? We know our vertex is 0, 0. We know we have the point -1, -1. Now, that point -1, -1, isn't that where that open circle is? But this isn't an open circle. This is a closed circle, right? Because it's less than or equal to. What does that mean for us? A closed circle trumps an open circle. So that means we're going to close this circle. So there's our V so far. And then the other point is 1, -1. Well, the other point over 1, down 1, again, aren't we right on that open circle? But this one is a closed circle because it's less than or equal to. So what do we know? A closed circle trumps an open circle. So close it. And there's our graph. All right, let's try another one.
Can we do it on our own?
You want to try this? No, I don't. You can try this next one on your own. I don't know how well you'll do with it, but try it. So I don't know how far you'll get with this without my help, but try it. I think you can do it if you all just think about it, but some of you just don't want to think. I don't know. I don't blame you. I never want to think.
Can you use APCSB test if you want to?
Is it C#?
The same y value or z value as that?
Then
Yeah.
Oh yeah, shoot. Isn't it supposed to be one?
And then there's like a lot of other
All right, are we ready to go through this or no? Anybody want more time? All right, let's do this. So the first thing I'm going to do is y equals 2 minus x. Well, this is a line. It's just not in the format we're used to seeing. Usually we like to see y equals mx plus b. So I'm just going to manipulate this. Y equals negative x plus 2, which is really a negative 1. What does that tell me? My slope is negative 1 over 1. My y-intercept is 2. So I'll start off drawing that line, and then I can always erase. So this line, y equals negative x plus 2. We're starting off at 2. And then we're down 1. So remember, our slope is rise over run. So our rise is negative 1. So we're down 1, right 1, positive 1. Down 1, right 1, down 1, right 1, down 1, right 1. I'm going to keep going here. I'm filling up my whole thing. I'm going to have to erase, but that's okay. And then we're up 1, left 1. All right, there's my line. But now I've restricted the domain. How have I restricted the domain? I'm now saying, well, this is the graph only in the scenario that the absolute value of x is less than 2. We briefly touched upon this a couple of times throughout the year, but it was never very long. So whenever you have an absolute value inequality, absolute value and an inequality, all right, if it's less than, it's an and situation. If it's greater than, it's an or situation. What do I mean? This means x is less than 2 and x is greater than negative 2. So whenever you have an absolute value inequality, when it's less than, it's an and situation. When it's greater than, it's an or situation. So this is x is less than 2 and x is greater than negative 2, which can also be written like this, right? Negative 2 is less than x, which is less than 2. It's between that interval, between negative 2 and positive 2. All right, so now I have to see. I need to be between negative 2, which is right here, and positive 2, which is right here. So anything that's not between negative 2 and positive 2, which is that yellow highlighted area, what must I do to it? Erase it. Exactly. Erase. Erase. All right, so that's my first part of this. Are we ready for the second part of this? Yes.
I'm confused about like why it's not like the other way around. Like why did you keep the other part of the user?
Okay, because of our restricted domain. When it's saying this is only true for the absolute value of x has to be greater than 2, in order for the absolute value of x to be greater than 2, x either has to be less than 2 and x has to be greater than negative 2. Why? I'm sorry, x is less than 2, sorry. When the absolute value of x is less than 2. Guys, I can't have you talking when I'm explaining something. So, mathematically speaking, anytime you have this absolute value and an inequality, if the inequality is less than, you split it into two different inequalities, flip the sign, and put an and in the middle. But, so it makes sense to you, think about this. Right, we need this ultimately to be less than 2. So they're saying it has to be between these two numbers. Let's make sense. Between negative 2 and positive 2. What's a number between negative 2 and positive 2? 0. The absolute value of 0, is that less than 2? Yeah. Negative 1, right? Absolute value negative 1, is that less than 2? All right. But now let's say we were just, let's say you said, okay, well, why can't we just be less than negative 2? Right? Is negative 4 less than negative 2? Yeah, I mean less than 2. Negative 4 is less than 2. So the absolute value of negative 4, that's positive 4. That's not less than 2. That's why this whole and situation gives us the numbers that are absolutely between those two. Okay. So now that was one scenario. What's my other scenario here? We're saying y will equal 0 if the absolute value of x is greater than or equal to 0. Greater than or equal to 2. Well, now the absolute value inequality is greater than. When it's greater than, what does that tell us? It has to be an or situation. If it's less than, it's and. If it's greater than, it's or. The way I think about it is if it's less than, you're more restricted, and the and is more restrictive. When it's greater than, it's like bring more to the party. It's less restrictive, so it's an or situation. So here we're going to have x is greater than or equal to 2, or x is less than or equal to negative 2. That's our new domain for y equals 0. So let's go back and graph y equals 0. Do we all agree this is y? Let's just highlight it. This is y equals 0. But it's not the whole entire line because of my restrictive domain. What is my restrictive domain? They're saying x is greater than or equal to 0. So, sorry, not 0. Greater than or equal to 2. So 1, 2. So that's going this way. And then it's saying x is less than or equal to negative 2. So that's 1, 2. That's going this way. What about the whole middle area? What should I do with that? Delete it. So that's what this looks like. All these should be closed. Oh, wait. Sorry. For this one, there was no equal to, so this is an open circle. Sorry. And this should have been an open circle, but what do we realize? Closed trumps open, right? So that's why that's still closed. Yes?
How painful is this going to be for you to grade on the test? Because our black lead with the paper on the graph will probably be a little difficult to read sometimes, especially before people put their points.
I mean, it's generally speaking not that bad. Yeah. Okay. Do you guys want to try one on your own? No. Try this one on your own.
We're lazy honor students.
Cause that's like.
Yeah, don't tell me anything. If we try, can we see our tests?
I have 2 more problems, then you can see your test. How about that?
So why don't we try the last one? I know we see our test. How we feel.
No. You guys try this one on your own.
Most is easy.
Oh, sorry. I have.
I meant to make it hard.
Yeah, I have one more. No, I didn't mean to make it hard. I'll just do one more. I have 2 more, but I'll only do one more. Yeah. Claudia, do you know Simon didn't do his homework?
Yeah, I know.
Shocked.
Simon, I hope you feel good about your
I'm shocked.
You know, a lot of some people also did better than me on the tests. So.
I do know that, actually. I made a mental note of that, to be honest with you. It's not your week, Simon. But Matt was on fire yesterday, so I'm pleased with him. I really was so pleased with him. we ready to go over this? No.
It's open circle for that purpose.
Can we go over it now? Yes? Okay. So, hush children, we have y equals 0 if the absolute value of x is less than or equal to 1. What do I want you to remember? It's an absolute value inequality. If it's less than, what situation is it? An and situation. So x is less than or equal to 1, or x is greater than or, oh, sorry, not or, and x is greater than or equal to -1. Doesn't that mean the whole domain from -1 to +1? All right, what does that look like? Well, y equals 0 is the x-axis, and we're going from -1 to +1, both closed circles. Are we okay so far? All right, the next one, y is equal to x minus 1 if x, the absolute value of x, is greater than 1. Well, this is a line, y equals 1x minus 1. Our slope is 1 over 1. Our y-intercept is -1. And our domain is going to be x is greater than 1 or x is less than -1. All right, so what does this line look like? We're at a y-intercept of -1. And then we're up 1, right 1, up 1, right 1, up 1, right 1. So all closed circles. Down 1, left 1. Okay, but our domain is restricted. It says x has to be greater than 1. So where is x greater than 1? Well, this would be an open circle over here, but isn't there already a closed circle there? So what do we know? Closed trumps open, right? So we're just going to draw our arrow going up where we're greater than 1. But then it's saying x is less than -1. So this is where x is -1. Go down. There's a closed circle there. Remember? Oh, no. So this is the same line. So now we're going to make this an open circle, and then we're going to go down. What did I do to all the points between? I erased them. So that's how this one looks. That's our answer, yeah. You can just draw the line.
So on the test, are you going to give us like
graph paper? Yeah, I'm going to give you graph paper.
Without it, I'm just like, like half an hour trying to draw.
Okay, there's one more problem we need to do together, and then we'll be done, okay?
Do you know when the test is or how many questions will be?
I know nothing. I can tell you next class, though, when I map it out. You drop tomorrow, so maybe Monday I'll tell you.
Is that 1?
1 minus the absolute value of x.
That one's already broken.
I'm sorry, y equals 1/2. Say that again, please. Well, let's record you this time.
Are we ready? Because you're talking, Dylan.
Yeah, shame on you, Dylan.
Wait, 1/2 less than x. I'm sorry, 1/2.
Oh, sorry. That should be a negative. Sorry about that. All right, now are we ready? We got this? All right. So the first one might look intimidating, but it shouldn't. Hold on, let me fix my graph to make it bigger so y'all can see what I'm going to do. Okay. So let's look at the first one. Y equals 1 minus the absolute value of x if negative 1 is less than or equal to x, which is less than or equal to 1. So I hope that you all recognize that 1 minus the absolute value of x is the same as saying the negation of the absolute value of x plus 1. Aren't these two the same thing? But the second way I wrote it, isn't it a lot easier to visualize what that looks like? So this is obviously a v that has been reflected, right? It's frowning, and it has been shifted how many units and where? 1 up, right? But now I have a very restricted domain. We know this is, you guys don't have to draw this. We know this is our parent function, right? But because it was negated, we know we're now frowning down. But then, because of the plus 1, we're shifting that 1 unit up. So do we agree we're going to shift it up? But you know what I'm going to do, guys? Because I have halves here, I'm going to say each slot is a half. So that's negative a half, that's 1, that negative 1, that's negative 1.5. Do you guys see what I'm doing? This will be 0, this will be a half, this will be positive 1, positive 1.5. This is half and 1.
Yeah, can you just say the intervals are like half?
Yeah, you can, but I'm just showing you. Okay, so what am I going to do? So now I know that my vertex is going up 1. So that's right there. But now we have that restricted domain, right? We have that restricted domain. So now I need to figure out where are my endpoints on this restricted domain. So we have x, and then we have the negation of the absolute value of x plus 1, and then, or sorry, y equals that. And then I'm going to have the point x comma y. Okay, so we're between negative 1 and positive 1, so let's see what happens at negative 1. Y equals the negation of the absolute value of negative 1 plus 1. The absolute value of negative 1 is positive 1. The negation of positive 1 is negative 1 plus 1 is 0. So this is the point negative 1, 0. So negative 1, 0, and we're a closed circle right here. All right. Then we're going to do the same thing with positive 1. What do we know that's going to end up being? The same. So now it's going to be positive 1, 0, right? So that's going to be right over here. Do we agree that's our V? That's our absolute value graph right there. All right, so now I have y equals a half if negative a half is less than x, which is less than a half. All right, well, y equals a half, isn't that just a horizontal line? So we're at a horizontal line at a half. But now, what are we between? Negative a half and positive a half on the domain. So we're right over here. And it would be open circles, but because it's on the graph, what do we know? Closed circles trump open circles, right? Yeah.
Can you just put an open circle like on the line?
That means that part wouldn't be included if you put an open circle. All right, we good? All right, so we are done here.